let's double check to make sure that this audio is there. Got to double check. Okay, the audio is there. And ladies and gentlemen, okay, so welcome back. We got a good day of log cosines again today. So if you said, wow, wonderful log cosines. Now remember, this stuff isn't going to go away, whether it's log sines or log cosines. It doesn't go away. Now, I say that to you, so hopefully it's something you embrace. Think of it this way. You're going to go away before log sines goes away, or log cosines goes away. So it's here to stay, and these are some fundamental ideas that are very, very, very good at having you do some applications. Applications are the name of the game. Now, I know sometimes it's kind of scary because you go, oh my God, these are word problems. These are problems with words, right? So I understand that because when I was a student, I was so apprehensive about taking like physics 1. And I was like, oh my God, that's all word problems. Everything's a word problem. So, I understand that apprehension because I used to have it. But, when you work on the math behind it and you know the math behind it, meaning you knew the log cosines we worked on yesterday, when you approach a word problem, then you just focus now on the language because you can't do it both. In other words, it's done in steps, meaning you first learn the math and then you learn the what? Language. That's how it works. And then you become successful. And I'll tell you guys, it's kind of an interesting story. I became such a good student in physics where I would get 100% on my physics tests. And you say, how did you do that? And the world thought I was a genius. I was no genius. It's because I did the math and then I did the what? Language. I didn't try to do it at the same time, It's kind of like thinking, how do you change a flat tire? Do you do it while it's moving? While the car is moving? Do you guys understand what I mean? You can't change a flat tire while the car is moving. You got to stop the car and then you change the tire, right? So that's kind of the idea. So you can do it. People have. If I can do it, I think anybody can do it. But you still have to go through the what? The steps, right? So hopefully, again, you worked on some of those things. You don't want to wait till the night before. It doesn't work that way. So what I'm going to share with you guys here is some of these application questions on how to calculate distance. Okay? So let's start by that, and let's take a look at that, and let's see. What does it say? It says calculating distance, and here's what this is. This is under the law of cosines. Now, when you read this, we see two straight roads diverge at an angle of 75 degrees. Now, when you kind of read that, in all honesty, for me, when I first read that kind of statement, I didn't even know what they're talking about. What are they talking about, right? Two straight roads diverge. Well, what they mean by that is that this is a straight line. This is a straight line, and it's not the same straight line. So, that's all they're saying. So when you read that, they go, oh, you got two straight roads, they're diverging. They're like going away from each other. That's kind of the meaning of that word diverge. And then as a consequence of diverging, what does it say here? They give you this angle of what? 75 degrees. Okay? So you go, okay, the roads are going away from each other. That's what it means to diverge, and it creates an angle. Right? So that first sentence, yeah, you want to focus on the language. It's kind of interesting to me that, when I talk to people and I talk to other instructors, whether it's, any environment that I'm in, I remind them, because I teach other classes, how important language is, to go through the language, right? It's extremely important. Language is very important. How to communicate is important, So 2 cars leave an intersection at 2 p.m. And you go, okay. So they're first talking about the road. That's the road in blue. Now they're saying, okay, 2 cars leave at an intersection, and this is the intersection right here. So if I had to go back and rewrite that, I might have just put intersection. So there's your intersection. and 2 cars are leaving at 2 p.m. You might say, why do they care about that? Well, we'll see. One is traveling at 55 miles per hour. And I'm going to call that, you know, what you call that could be different things, right? I mean, C1 for car 1, I don't know, X, Y, whatever, A, B. In this picture, looks like I might have called it A. And maybe B, I don't know, okay? But let's see if we can figure something out, right? One is traveling at 55 miles per hour, and the other is traveling at 72, right? So there's 2 cars, miles per hour. How far are the cars apart at 4:30 p.m., right? A classic question, ladies and gentlemen, of log cosines. Let me share with you guys why. If I ask you guys this common sense kind of question, right? If one car is faster than the other and they're traveling, do you guys know the distance formula? What's the distance formula? You guys know the distance formula? This is an extremely important formula. Distance equals rate times time. Okay? That's an extremely important formula. Distance is rate times time. So one line is longer than the other. Would you guys agree with that? A, B. So what do you think? What do you think then I should say? Well, how do we figure out which is which? You guys know what 55 represents? This 55 miles per hour? You guys know what the 72 miles per hour represents? What does that represent? That's your rate. Distance is rate times time. It's your speed, right? And if the time of this situation starts where? At 2 p.m. and it ends at 4:30 p.m., right? What's your time value? What's that time? If you started at 2 and you ended at 4:30, how long have you been traveling? Do you guys know? How much? Would you guys say that's 2.5 hours? What do you guys think? 2.5 hours? Does that make sense? 2 to 4:30, that's 2.5 hours, right? Later. From 2 to 3 is 1 hour. From 3 to 4 is 2 hours, 30 minutes. So, ladies and gentlemen, there's your time. So I want to remark to you guys that the units have to be the same, miles per hour and hour. And so now we can figure out the distance here, okay? So for one car, we know the rate is 55 times 2.5. The other car is what? 72 times 2.5. Is that right? Which one do you think is going to be A? Which one do you think is going to be B? Which line is longer, A or B? B. So this has to be B and this has to be A. Is that true? Did you guys see the point? See, think of that distance formula here. D is RT. Think of that as a ruler. That's how I think about it. It's a ruler. Distance is rate times time. So now let's wake up the TI. Okay. So now we have what? 55 times 2.5. And what do you get? 137.5. 72 times 2.5. What do you get? 180. So A then is going to measure what? What's that distance there, right? For A, 137.5. Is that right? And of course, that's in miles. And then B is 180 what? Miles. So what I want to go back and share with you guys is this kind of stuff here. Okay? Calculating distance. So what we found is distance here. It's a classic question. These questions are classic. These are what we call bread and butter. You got, what do you mean? What's bread and butter? If you're taking law sines, law cosines, working on an application, these are the kind of questions that are like your meal, bread and butter, right? It's a staple. Now notice what I did here, okay? How I've expressed to you guys law of cosines. What you're seeing is a side angle side situation, right? That's an extremely important detail. Side angle what? Side. You guys with me on that? So, what do you think this becomes by law of cosines, ladies and gentlemen? Do you guys remember this? What is the law of cosines without me going back and taking a look at it? You see that? You see that distance, that letter D? Because that's what they're asking. How far are the cars apart at 4:30? They're asking for this distance D here. And maybe we should use another color. Let's use another color. I used red yesterday for it. But here's the thing. This is why you guys want to get started on that fundamental thing. We can always find D very easily. This is, for me, the classic law of cosine scenario. It's classic. So remember, I gave you guys a bunch of formulas there. We wrote it down. Did you guys print out the notes for yourself by any chance? Maybe. At least write them down. It's a good thing to do. How have I been approaching law of cosines? How do you guys think I've been doing that? What do? You start with that D squared. This is always about finding that opposite distance to the angle, right? And then how do I think of it? What do I say? Do you guys remember? I say things, think of what? Pythagorean theorem. A squared plus B squared minus 2AB cosine now of that 70, well, cosine, really, I'm changing the letter on you, but I want you guys to see my point. I called that big D, but you guys know big D is really 75 degrees. Is that right? You guys see that it's the opposite angle. So if I know the sides, and I do, I don't even care what letter they represent, really. I just care about the values. So what is D? D, ladies and gentlemen, is going to be the square root. Is that right? Now I can solve for D by the square root formula. There we go. So go to your calculator. Second square root. Here's the deal. What is this? 137.5 squared plus 180 squared minus 2 times 137.5 times 180 times cosine of 75 degrees. You guys okay with that one? And what do you guys get there? What's your distance? Let's go out to the nearest tenths again. Let's be a little bit more accurate, because going out to whole numbers is kind of not as accurate. 196.2. And what are the units? Remember, those science instructors, woo, they want units. Math instructors, you know, we don't really care if you put units as long as you know it's a distance. But those science instructors, I'll tell you, they will be livid if you don't put the units. So I'll help them out and prepare you guys for that. So this is your distance, ladies and gentlemen. And again, for me, it's a classic law of cosines question. Side, angle, side. Find the opposite side. All right, what do you guys think? Is that okay? Yeah, there you go. Calculating distance, ladies and gentlemen. So that's a classic question. So I'm kind of introducing to you guys, you know, if you even look in your book, for example, and I'm going to go back to, where are we at? Law of cosines on my sheets here. Look at this. You know, just to kind of take out a law of cosine scenario, let's go to the book. All right, let's go here. $241, and oh, we go. Here we go. This kind of always takes some time, but oh, today it did a little bit. It was a little quick. Here's my point. Where was it? Where's the one? Yeah, we got to talk about some of this stuff. This is good stuff. Well, area of a parking lot. Yeah, no. Where was the example? I just want to kind of, we're going to get here for heading and bearing, but ladies and gentlemen, there we go. Length of a tunnel, you know. It's another classic law of cosine questions, meaning they're going to give you side, angle, side. And they're going to ask you for the distance of the opposite side. Classic, classic, classic. You know, they go, tunnel is built. So this is, what I did is analogous to all of these kind of questions. But let's look in the book here, and let's find something to kind of look at, which I think is good. You know, even looking at, where are we at, 30? No, the book goes up here. How about this, like 37? Now, it's important to me, ladies and gentlemen, it's extremely important to me that when you go to those classes, like maybe a surveying class, right? Because this is what you guys are majoring in. You know, you want to major in things like this. You maybe want to major in, that's going to have you a civil engineering course or an engineering course or just some other science course that involves surveying. You should show up there knowing what to do, because that's what you're going to cover. They're going to cover this stuff. And, going to those classes with you not knowing how to do that is like blasphemy. You know what I mean? So what I'm saying is, if we just look at number 37, I'm going to change that on you guys, right? Look at the picture. Didn't they give you side angle side? So they're going to always ask you for an opposite distance for side angle side for things like log cosines. And they're going to say, find the distance across a small lake. A surveyor has taken the following measurements. So you can take some measurements here. Find the distance across the lake using the information. Now, I'm going to change this on you because I don't want to take all the fun away. Okay? And I'm going to use the same letters even, B, A, and C, but I'm going to change some things on you. You guys can see what I'm saying when I actually show this to you. But, they didn't even use a lot of language. They just said, find the distance across the lake. They just drew a triangle with letters, and then they just drew there for like number 37, I'm saying. And then they just told you, hey, find that distance. So anyway, whatever. That's the same as what I'm looking at here. But I changed some things. Okay? And the distance they're talking about here again, using the colors of this day, is over here. So in other words, I want you to find D. And what kind of situation are you in? Side angle side. Side angle side. So, okay, again, what do we want to do? You guys remember? Think of it this way. Here's what I do, right? D squared, what does D squared equal? Do I really need to put the letters? I don't. I don't put the letters, right? You know what I do? I say, okay, it's the side squared plus the other side squared minus 2 times the product of the sides, right? And then cosine of what? 42 degrees. What do you guys think of that? Do you guys see my point? I'm using how I described how to memorize this without even memorizing a formula, really. How to go approach it. Now, you're not going to master it unless you practice it. So you can't just go, oh, if you need the letters, and put the letters. But you got to practice it. And then you say, well, how do I get D? Well, that's taking the square root. So you take the square root of this. So, okay, here we go. Here we go. Here we go, ladies and gentlemen. Let's enter this in our calculator. What do we do, right? Square root again. Remember, you take the leg squared, 3.6 squared, you add it with your what? 4.5 squared minus 2 times 3.6 times 4.5 times cosine of what angle? 42 degrees. And ladies and gentlemen, what do you end up with? What's that distance in this example? Let's again go to the nearest tenths. What's that to the nearest tenths? Do you guys know? 0 is in the tenths position. The digit to the right is a 2. What does that mean? Do you guys remember? Yeah, it's keep the 0. In other words, don't add 1 to the 0. When do you add 1? If the digit to the right of the place value is a 5, 6, 7, 8, or 9, right? So here you go, 3.0. So this is 3.0. No, not miles. That's in what, feet? So ladies and gentlemen, this is classic law of cosines applications. Easy breezy, side angle side, you know. It's very classic. What do you guys think? Is that impossible? No, it's really being trained, in all honesty. If you ever want to get, is anybody here good at anything? I'm just curious what you're good at. What are you guys good at? You got to be good at something. You good at anything? What do you guys think? Anybody good at something? Nothing? Well, maybe. You're not good at anything? I had this conversation with my daughter. I remember I said to my daughter, I wanted my daughter to play sports. And she liked playing sports. She liked playing. But she didn't want to get into organized sports. I wanted to play volleyball in high school, right? Because she liked playing volleyball. She just said, Ashley, why don't you play volleyball? You know, why don't you try for the volleyball team? Or why don't you try to focus on that, right? She says, no, Dad. Well, why not? Because I'm not very good at it. So, well, how do you think you get good? You get good by practicing. That's the only way you get good at anything. See, there's an assumption that people have natural ability and they're just good and they excel. And because they're good at something, that's the assumption. But the truth is, that's not really the case necessarily at all. Maybe you have some natural ability. Maybe you have some inclination, but that doesn't mean you're going to be good. The only way you get good is by what? Practice. Now, how did I learn this? I'll tell you. I played organized sports. I was very good at baseball. I didn't start out that way, but I practiced every day. I got very good. But I'm too small. Nobody cared about small baseball players. They only care about the tall guys. It's the truth. That's why you see baseball players 6'2", 6'1", 6'4". You don't see very many Mookie Betts out there. Although Mookie Betts is more athletic than any of these guys. So anyway, so how do you get good? You practice. Where did I learn that? I remember watching, there's a basketball player by the name of Magic Johnson, and I was a kid. And I remember somebody asked Magic Johnson, how did you get so good at free throws? Because he had an amazing free throw rate. He'd always try to get the ball and get you to foul him so he can get some points by doing free throws. But you got to be good at free throws. So how do you get so good? You guys know what he said? Every morning when he wakes up, he does 100 free throws. Every morning. Before he does anything, he does 100 free throws. Before he brushes his teeth, 100 free throws. And that was shocking to me. I thought, but you're Magic Johnson. That's why they call you Magic. I thought you're born with all that natural ability. You could do this stuff. He had to work and practice. He may have had the height. He may have had all those other gifts, but he still had to practice a lot, and he became great. So that said something to me. If I want to get good at word problems, if I want to get good at math, I'm going to practice. I have to. So that's what I did. And it worked. So you're not born with natural ability. You may have a little bit of it, but it comes through practice. Only way to do it. So if you don't practice, you're not going to get there. So don't get mad at yourself if you say, hey, I can't do something. I haven't been successful. If you didn't practice, that's the reason. Don't tell yourself anything else. It's because you just didn't practice. If you practice, you would be good. That's it. And so that's going to help you get good at anything you want to do, but you got to want to do it. And so I wish my own daughter would have said, taken my advice and just practice volleyball because she didn't want to play, but that's what a lot of people do. I've seen that in a lot of people. They're too afraid. They're just afraid. And that's kind of sad if you walk around this planet your whole life afraid of everything. That's sad. That, to me, is heartbreaking. Notice that. Take a look around. Take a look around people you know. You might see they're just too afraid. Too afraid of being successful. And to me, that's heartbreaking. But if you practice, you'll get good at anything. And there's some things even now for me I want to get good at, but I have to practice. So let's take a look at some more of these applications here. Oh, another classic question. Man, I'm glad I made this stuff. Do you guys know this is a classic question too? The mountain question. So let's go through and let's read this. Let's do this classic question. A man walks toward a mountain along a flat surface. And even when I've read this, I remember as a student going, what do they mean a flat surface? All they're saying is that this is a straight line. That's all they want to communicate. You go, okay, a man, it could be a woman, doesn't have to be a man. Walking toward, because the mountain is over here, right? So you're walking toward the mountain along a flat surface, straight line, and measures what? An angle of elevation to be 32 degrees. So if the person is walking toward the mountain, remember the definition of angle of elevation? You guys remember I said that to you? I make a reference to it, 32-degree angle of elevation. So somehow, and this is kind of a weird thing, remember, the eyeball's on the ground. Remember, you have to have an object, and if it's elevated, it's up. So this is what they're talking about. You're talking at the top of the mountain. There's the object in some sense. So yes, even though the man is walking and his eyeballs are probably 5 feet tall, that's what they're pretending. That angle of elevation is 32 degrees if the person was on the floor there looking at the top. So remember, that's the definition, where this flat surface is that horizontal. Because remember, there's a definition there. This is the horizontal. And then they say, what does he do? He proceeds to walk another what? 200 meters. There's your what? 200 meters. And then what happens? They measure another what? Angle of elevation. And what is that going to measure? What's going to measure now? 38 degrees. So the eyeball again is down here. And remember, it's an angle of elevation, and it's to the top of the mountain. And that's kind of what an angle of elevation is. You have to have an object that you're looking at to measure that angle. And then what's the next question, ladies and gentlemen? What do you think that next question is? What are they asking? How tall is the what? Is the mountain? If somebody asks you how tall you are, How do you measure height? Think about this. It may not see, it is a big deal. If they ask you how tall you are, how do they measure? Wish I had my sound effects. God, I missed that. I'm gonna put a to-do list together. I got things to do today. Where's my let me get out my phone. If I try to forget, it's funny. I ran into my colleague. I'm going to get my coffee. He says, "Where are you going?" I go, "I got to get my coffee. I always forget." He goes, "So do I. I forget all the time." Oh my God, I thought it was just me. Getting old. Here's my to-do list. To-do. Sound effects. Send. Letter. A rec. Jesus. All right. Got like 5 things on my list. How do you measure height, ladies and gentlemen? Height is always measured how? Here's my point. Vertically. It's not vertical. Vertically is how you measure height. And that makes this a what? A right angle. Now, maybe you might say, hey, your ground is maybe over here. Can we put the ground over here this way, right? So here's a picture. Now, I titled this worksheet Law of Sines, Law of Cosine Applications because I decided when I created it, when I've done this, and if you get into other classes, I've decided, you know what we're going to do? I'm going to do it this way. I'm going to talk about law of sines, law of cosines, and I'm going to do some applications of it. But I did it a little differently. I did law of sines and then did some applications. Now I did a little law of cosines and now do some applications. So what I want to remark to you guys is, how do you go about finding the height? Because that's what they're asking, the height of a mountain. This is a classic mountain question. Every trig class should have that example that you take. In the world, anybody take trig in high school? Did coach have the mountain question? Oh my God. Did coach take trig? Probably not. Shouldn't there be a law against that stuff? Should you be able to go to a doctor that didn't go to medical school? Should you go to a dentist who didn't ever go to dental school? What do you guys think? Should you get on a ride at Disneyland created by a person who was never an engineer? Should you take counseling advice from a counselor who never took courses in that subject? Oh, Mr. Judge, you're being mean. Should you listen to people who never did these things before? Should you take photography from an instructor who never took a picture in their life? It makes too much sense. Anyway, what's my point? Does that look straight to you guys? Does that look vertical? I don't know. All right, ladies and gentlemen, here's the deal. How would you guys approach this? Why is this coming after law of cosines? Why do you think I put it under the law of cosine situation? Anybody have an idea? They want us to find the height. Didn't I get through saying to you guys, side angle side is law of cosines? Here's what I'm going to say to you guys. You know how you do this? You can do it in steps. You're first going to have to find length what? D. How do you think you do that? Do you have side angle side? Oh, maybe it isn't law of cosines. Oh, it's not law of cosines. I apologize. I haven't had my coffee. Angle side angle. You still probably need to get D anyway. You don't have to get D, but you can. Why do I say it's not law of cosines, but law of sines here? Anybody know? Do I have? Yes. Yes, you can. You could get this angle right in here. You say, how is that? Isn't that 180 minus what? 38 degrees. And what's that going to give you? Anybody know what that is? Isn't this 142? Yes, it is. Outstanding. Bless you. And you have what? Angle side angle, ladies and gentlemen. Angle side angle. Isn't that going to give you D? I think so. Let's figure this out. Okay, angle side angle. Once you know that this is 100, and let me double check because I haven't had my coffee. So I remember, maybe I shouldn't do my arithmetic in my head this morning till I've had a full cup. 180 minus 38 degrees, because it's supplementary angles. It is 142. Now, you know what I'm going to do? 180 minus what? 32 minus 142 is going to be 6 degrees. Does anybody want to tell me why did I do that? Why am I doing that? Because if you're ever under angle side angle, what could you always do? You got two angles, you get the third angle. Those two A's represent angle. The sum of three angles is 180 in a triangle. So this here, and I'm going to have to start to erase, but this here measures what? 6 degrees. Okay, you guys okay with that? So good. So what that now means, let me go back and do something like this and say to you guys, so you can see this here, that you got the angle side angle situation. So let's see what law of sines says, because this is under the application for both law of sines and law of cosines. Isn't that sine of what? What do I know? Sine of 6 degrees, right? Over what number from law of sines? Sine of 6 degrees over 200. What does that equal? Remember? Opposite. 6 degrees over 200. What does that equal? That equals what? Sine of 32 degrees over what? Over D. Cross multiply. You guys okay with that? What do you get now? D. Sine 6 degrees becomes what? 200 sine 32. And when you solve for that letter D, right, divide both sides by sine 6, right? So you get D going to be what? 200 sine 32 degrees over sine of 6 degrees. So let's see what D will be. Okay, let's get out our calculator. So we're going to get this D now, ladies and gentlemen. So let's see. 200 sine of what? 32 divided by sine of what? 6. And what do you get? What does that equal? Do you guys get this here? 1,013.9 feet. Is that right? So that is that distance we call D. Okay, but that's not the height of the mountain, is it? What you guys found, oops, bless you. It's all right. Guess what, ladies and gentlemen? What are you guys looking at now? Here's what I want you guys to see now. You found that D, that distance. Why is that distance good? Why do we need that? Because what are you looking at now? What is that? To get the height of the mountain, isn't that a right triangle? That's the whole idea. So you got that two-step kind of situation where you have to use law of sines, and then you could get the height of the mountain. Now, you're going to have to know about a trig ratio. It's really geometry, right? So what is that? Do you guys know? What's opposite over hypotenuse? Right? Because you have 38 degrees. Isn't that the angle you have? You have 38 degrees there. So what's the deal? What's the right? That's why I give you guys that work to do on right triangles. What's the deal? Because I knew where we're headed. So I think, what ratio is that? What's opposite of an angle? Because here's the angle. Opposite over hypotenuse. Isn't that sine? Sine 38 degrees is opposite over hypotenuse, 132.9. So that means H will be, solving for H, sine 38. So we get 1,013.9 sine of what? 38 degrees. What's this going to give you now? What's the height of the mountain? 624.2 feet. Okay? 624.2 feet. So, ladies and gentlemen, that's what H is. That's the height of your mountain. That's the classic mountain question. Very classic. Okay? So again, if you take any trig course, they should have you do that. The mountain question. All right. What do you guys think? Not bad? How about this? This is another sort of classic questions where you say dead reckoning. You ever hear that phrase dead reckoning? I'm not so sure I'm so familiar with that phrase dead reckoning. I got to admit that. Got to have to look it up. What is dead reckoning? Look it up. Dead reckoning phrase. let's do that here. How about this? Okay, I'm going to share with you guys dead reckoning because, what if you are in a situation where you're not sure? And I think that's probably good to look it up and think about this, right? So let me share that with you guys. Let's go to the browser. You know this phrase dead reckoning that we're looking at? Okay? Dead reckoning, it's called also known as deduced reckoning, is the process of calculating current position by using previously determined reference position. And advancing that position based upon known or estimated speeds over elapsed time and the course. All right, what does that even mean? You know what that means? Let's go to the iPad. You know what that really means? It means you take a measurement at one point in time, and then as you proceed, you take another measurement to correct your position. It's called dead reckoning. Okay. Take a measurement, proceed, take another measurement, and you adjust. It's kind of like a weird common sense thing in a way, right? Like if you're going from one location to another, let's say you're traveling from home to McDonald's, and you're traveling down one street to get to McDonald's, then you have to change your position to continue your travel so that you could get to your destination. That's kind of what they're saying for dead reckoning, So pilots evidently have to do that. So here's what they're saying. Dead reckoning. A pilot travels for 2.5 hours along a straight path. All right. And then makes a course correction. Okay. So the course correction is heading 35 degrees to the right of the original path for an additional 2 hours. Maybe you have to read that sentence 2 or 3 times. That's fine. You read it over and over again. So what they're saying is, here's the deal. Evidently, the pilot is traveling this distance. For how long? 2.5 hours. Is that true? You guys with me on that? What's the distance formula? Distance is rate times time. Now, what do you guys know about this? You just know that distance, whatever it is, maybe we need to label it, but they don't even give you the rate. Maybe they do. Let's think about this. So that's a certain distance. It's rate times time. We know in this case here that the time value is 2.5 hours because they told us that. And then corrects that and goes to the right. And you go, oh, we're going to the right now? I guess so. In other words, from that location, the pilot goes to the right by an angle of 35 degrees. For an additional what? 2 hours. So I'm going to put my time over here. Time is 2 hours. And I guess I'm going to put that distance. Oh, we already have a label D down here. So let's call that A, like before. And then let's call this B, I guess. Okay? Because we already have that D down there somehow in the picture. But whatever. If the plane has maintained a constant speed. I get it. What's the rate? The rate is 600, ladies and gentlemen. My R is 600 miles per hour. Okay. I see their point. How far is she from her starting point? In other words, This is where the pilot ends. This is start. This is the ending. Ah, how far? They want to know that distance d. Okay. All right. So, ladies and gentlemen, we're going to have to do some arithmetic, okay? Let's do some information here because obviously we're going to have to solve a triangle. Distance A is rate times time. So distance A is at 600 miles per hour. Maybe you want to put mph times the time isn't that 2.5 hours, right? And then distance B now, you say, what's distance B? Distance B is rate times time. So distance B is going to be that same 600 miles per hour times 2 hours. And let's be consistent and say mph times the 2 hours. So distance B is really 1,200 what? Miles? I don't need a calculator for that one. 600 times 2. But what's 600 times 2.5 to get distance A? Right? Because this is the distance formula. Rate, and then each one of these is a time value, right? So we got time here. So what does A become? A is 1,500 miles. What is B? 1,200 miles. And we can already start to see, ladies and gentlemen, remember, here's the A value. I'm gonna remove this color here. So in blue, we found A, right? And in purple, we found B. I can already see what kind of situation this is. Does anybody know what I'm talking about? How can we find D? What do you think we need? I need that angle, don't I? Because what we have, I can already see it. Do you guys see it? Isn't that side angle side? We have a side angle side situation. So, okay, how do we get that? How do we get side angle side? What's that angle? What do you think, Elizabeth? Is Elizabeth correct? How does she know it's 145? Is this a straight angle? Supplementary angles, 180 minus what? What's that? Is that 135? Straight angle, is that true? So, ladies and gentlemen, there you go. Law of what now? Is that law of cosines? You say, how do you know that's law of cosines? Because they want me to get D. What is D? D squared becomes what? Was it 145? I'm sorry. Or 135. Oh, sorry. There is a typo. Thank you so much. Let's go back to the calculator. 180 minus 35. And that's going to be 145. You are correct. Typo. Not typo, but an error there. 145. Thank you. Okay, folks, remember how I look at this. It's kind of like Pythagorean theorem, although it's not Pythagorean theorem because we don't have a right triangle. It's a non-right triangle. But there is so many different things that I memorize, like the distance formula. But it's very simple. This is a classic law of cosines question where you have to get an opposite distance from an angle in a triangle where you have side angle side. This is classic law of cosines. And remember, this is d squared. So what is d going to be? Do you guys remember? D is going to be what? The square root of all this. So how do you get this value for d? Second square root what? 1,500 squared plus 1,200 squared minus 2 times what? 1,500 times 1,200 times cosine of 145, right? So cosine. Close that. And ladies and gentlemen, what do you get? Double check my work, okay? I haven't had that coffee. I left it in my car. Did I make a mistake? Let me double check. Yeah, let me double check. Anybody else want to second that answer? Can I go up here? Let's try it again, just in case. Let's compare. So is it 1,500 squared? It is. What's the other length? Is it 1,200? It is. Minus 2 times what? 1,500 times what? 1,200 cosine of what angle? 145. Oh. No. What's that? Did I do a mistake? Well, I made a mistake too. What angle did I put? Did I put 135 cosine? Oh, forgot to square the 1,200. Yep. Okay, let's try it again. There's three times is a charm. So maybe I had it right the first time. 1,500 squared plus 1,200 squared. Let's square that. Minus 2 times 1,500 times what? 1,200 times cosine of what angle? 145. And what do you end up with? 2,576.6. So we were good originally. Okay. And so, ladies and gentlemen, that's how far, that's the distance. That's how far. What is it? 2,576.6. There you go. Dead reckoning. That's how far you are when you start to end. Okay, you guys okay with that? So, this is a very interesting process. And again, it's important to understand these little processes where you can be traveling along a path and then you make a course correction. And then, yeah, you want to find out how far you've gone. And anyway, ladies and gentlemen, and so let's do a little something here. I want to, we got this navigation kind of question here, these navigation questions that are classic too. Because, I don't know about you guys. Let me just kind of say this. Let's go back to the law of cosine somewhere. You have GPS, but, once upon a time, how you navigated was not by a GPS. But you might say, well, why do I have to go back and learn the old way? Well, what do you think's in the GPS? You guys know the technology in the GPS is law of sines, law of cosines. So you do have to know some fundamentals about navigation, law of sines, law of cosines, because one day you might take some courses and they may have you program, using law of sines, law of cosines. And don't be afraid of that challenge. It's not, it's not the end of the world, but you got to have some knowledge and information. So, do you guys happen to know about how a compass kind of works? Navigation, course, bearing, and heading. Do you guys know what I mean? So this system is a system. Ironically, it's international, but it's actually done differently in different parts of the world. It's kind of an interesting thing. Is it up north, down south? What do you call going to the right? East? Good. And then the other one is what? You guys know what I'm saying? You guys know how to do this. It's not a big deal. But in navigation, this idea of bearing and heading, they might say, hey, north, 30 degrees east. See, what they're going to do is they're going to give you an angle right in here, okay? That's a 30-degree angle. So how do you start to determine the direction? Kind of called bearing and heading. That's known as the direction. But the language is under bearing and heading, okay? So, it's kind of thinking of, you're like starting right here and you want to know, where is north 30 degrees east? So let me express this to you guys how this works, okay? They're going to start here with north or south as you read that left to right. So here's the north direction. 30 degrees is the direction from north headed where? East. So this is kind of a northeast heading. Does that make sense? If they say northeast? Okay, but where's the 30 degrees? This is what you guys want to know. 30 degrees, ladies and gentlemen, starting to look at it this way. You start with the north information, and then you do what? You rotate in what direction? East. Start north, rotate what? East. Start north, rotate where? East. How much? 30 degrees. So this angle is what? 30 degrees. Easy peasy lemon squeezy. This is the direction. North 30 east. And if I said to you, what if they gave you this example? And that's what they're going to do. They're going to start here by saying to you, okay, what if it's south 10 degrees west? Well, You got to start now where? You got to start with the south direction. So that's the first information they're going to give you. And then you got to head how much? 10 degrees in what direction? West. Because you're reading that, ladies and gentlemen. You're reading this. Southwest. Isn't this southwest? Start south and head west now, right? Because this is the west direction. But how much now? How much you're going to have to go? 10 degrees. So here's what we have here. And then how much does this measure here? What's this angle, ladies and gentlemen? That angle's what? That angle is 10 degrees. So you guys are learning how, I'm going to start you guys off with learning how to work with heading and bearing, because a lot of times there's other examples that use this information to describe a direction. So we need to know, what does this actually mean? You just read it left to right. North, start there, and then they give you an angle, and then they tell you, more information of where to go. And they always start north and south, and then they give you an angle, and then they say to you, okay, east or west. Now, I just want to say to you guys, I've been teaching this information for a long time, and other parts of the world, you guys know, they do it backwards. Because I've had some of my students tell me they don't do north-south starting. They do east-west starting. And then they go, north-south. It's kind of a weird thing. They do it backwards. But it's interesting. But we're starting, to work with more applications, but this time with other information like heading and bearing. And that's why when I say to you guys, take a look at what I have here. If you look further, you go, oh, my God, Mr. Judge. They got these navigation questions. And they gave me, north, what is that? North 50 degrees east? What does that mean? South 80 degrees east? What does that mean? What does due north mean? What does due south, due east, due west? I haven't shown you that. But due north means you're only headed north. Due south means you're only headed south. But anyway, that's where we're headed. So we are going to tackle that. And to let you guys know, I did put some homework. Do you guys have that homework in Canvas, right? Here's our textbook. So if you guys notice, oh, here we go, assignments. If you guys notice in Canvas, what's the deal? We do have law sines, law cosines, and you do have some applications in that there. So I'm gonna say to you guys definitely want to get started ASAP, because you don't learn this overnight. You don't learn it the night before. You don't even learn it the weekend before. And sometimes students, they do that stuff. They go, I like these other classes better than this, and they put math on the bottom of the to-do list. And when you do that, you do yourself a disservice, because you're gonna find out like math is a very, very it's like a relationship. If you don't make it a priority, it's not gonna make you a priority. And you want to remember that. You got to make it a priority. So anyway, ladies and gentlemen, I hope you guys enjoyed the lecture. I hope you guys enjoyed the benefit of law sines and law cosines, because now you can do something significant, focus on the language, and there you go. And we'll see you guys. Is today Thursday? I guess so. All right, you guys, take care. We'll see you guys on Monday. Have a great weekend. All right, everybody. Good afternoon. Good morning, actually. Sorry. Let me get my bearings straight. And it's kind of ironic because we're working with heading and bearing. Is that right? So let's just make sure everything is good to go here. It looks like we're okay. Yep, audio is up. And we should be fine. We got a few people at home. Okay. So yeah, we were working with some applications of law sines, law cosines. We're going to look at some historic applications, things that are in your GPS, navigation, And, you know, this is historically how people use law of sines, law of cosines. So, ladies and gentlemen, let's take a look at this here. Heading and bearing, that's kind of describing direction. Now, we started to talk a little bit about it. So, what I'm going to do now is this here. Let's talk about, remember, you always start, it's going to look something like this. You start either with north or south. You got an angle, and I'll say you either have north-south angle, and then you have an east or west. So let me describe it a little differently here. Okay. So north, comma, or dash south, or you'll see east, west. And you're just reading this left to right. So we've seen a few examples already before we left for the weekend. Heading and bearing, and, you know, we want to describe our angle. Now, remember a few things here. Your compass looks like this. This is how a compass looks, and this is where it comes from, okay? And so I'll erase a few of these here, and we'll start to continue with our applications. And ladies and gentlemen, let's see, what do you think it would be if they said, okay, you're heading in the direction north, 25 degrees west. So this is a northwest direction. Notice I'm reading left to right, northwest. So north, again, right in here, 25 degrees, and then we're heading west. So you might say, how does that work for us? Well, ladies and gentlemen, how does that work? How do you think that works? You start again what? Due north. This is due north, by the way. Due north is just straight up. That's where north is. Now, where is the direction of west? You're going to have to rotate west. You guys with me on that? So you're going north how? West. So northwest. But northwest, how many degrees? 25 degrees. So this somehow is supposed to measure what? And if I draw just a regular line, maybe that's better than a highlighter, but I think you can see a highlighter a little better. This measures what? 25 degrees. So this is the system. It's not the standard angle system. So they're describing this in a northwest direction, okay? All right, you guys okay with that one? So I just want to kind of remark about this. There's your northwest. And then what if they give you another example and they say, okay, what if they say south now? South, 60 degrees east. So we got a southeast direction now. So you're going to start going in what direction now? South, and you're going to start going due south. So now you say, what do you mean? What's due south? Well, that's kind of due south. Well, not kind of, it's exactly due south. Let me do a nice what? Arrow. So this is due south, okay? But you're going to have to go in what direction now? Not just south, but what? East, okay? So you're going to go southeast. So you start due south, and you're going to go in the southeast direction. So that's what they're saying. But what's the angle now, southeast? The angle is what? 60 degrees. So somehow, I'm going to draw this line here, okay? This is supposed to measure right in here, 60 degrees. There you go. And it's south 60 degrees east. So ladies and gentlemen, there it is. There it is. So I want you guys to understand that there's a way to describe a direction, and that's called heading and bearing. This is a navigation system. Okay, so you just read it left to right, and then I'm going to give you guys something here to describe it. What if they say due north? What do you think due north looks like? I'm going to change that color, change it to purple. Due north, ladies and gentlemen, is just going straight up, straight north. This is due north. And then similarly, what if they said to you, due south, right? How do we describe due south? What do you think due south really means? I'll change the color. You're going straight what? South. Is that pretty simple? Okay. What if they said to you, due east? Where is due east? What do you guys think? Due east. Due east is this way. And then due what? Where's due west? What direction is due west? Let's pick another color, maybe yellow. How's that one? Okay. So here's the direction due west. What do you guys think? Easy peasy lemon squeezy? So this is describing direction. Yes. Try to go, scroll if you can. It's kind of odd. Let's see. Let me see here. You know, let's see, preview. Yeah, so it's saying that this is I think it was black when we started because I was trying to fix the audio. And then it should be what? There, once that audio got fixed. So there was a few minutes that the audio was going. But please monitor that, to tell me, because I did switch the audio. It's saying that you have this now, and I do want to save this stuff for a later date, for later. I'm going to do some editing with some of these applications there. So monitor that and see if it scrolls and gets to the video. But when I look at preview mode here, right, it says this. So let me do a few things here. Let's do a few chores just so you guys know. I'm going to go to the browser here. And do some chores. Now, here's kind of the weird thing, though. I have people here online, but it has 0, so I don't know why that's happening, but whatever. But let's go to the browser just for some chores. Odd. Let me go back to the iPad because I'm going to have to. Let's see what's going on. All right. I don't want everybody to get my password. You know what I mean? Did it eventually go live? Huh? Okay. Okay, let me do something here. All right, so it seems like we're on. Let's go to the browser. I'll upload a video of this. It's supposed to be. All right. So that's going to be your new link, so you may want to hit refresh. And so we're just kind of reviewing at the moment here the newish. What is it? The newish. Let's see if our audio levels are good. They're good. I sent people a new link, and we should be fine. All right. So we're reviewing heading and bearing, right? This is where we left off from last time, heading and bearing. What we added new today with our heading and bearing is the direction of due north, due south. Due north is straight up and down. Due south is straight down. Due east is to the right, and then due west is to the left. So we're doing some, some navigation here. It's just a way of describing direction. All right. So describing direction, and I'll check on my end as well. All right. So, okay. Yeah, it's going there. Okay, folks, we're good. So, does anybody have any questions on that kind of stuff here? You guys clear with the compass? Up is due north, down is due south, to the right is due east, to the left is due west. And we generally read it as north, angle east or west, south, and angle east or west. You just read it left to right as you're reading a book. And then you say, okay, well, how do we use this, or why do we use this? Well, we start to get to some kind of interesting applications here, right? This is kind of where we left off, ladies and gentlemen. And these are personally some of my favorite applications because, it's a very realistic situation. And so let's go through and let's read this, right? These are word problems. I did start to say that I did send you guys some extra credit. Is that true? Right? So I did want to go to the browser, talk about that. If you go to the assignment portion in the browser now, if you guys notice, I have been giving you, hopefully you're connected to Canvas like I've asked. And so I have been giving some people, to keep them honest, on some extra credit. What do I mean by keeping people honest? Homework on right triangles, area and arc length, law sines, law cosines, these kind of things. Stuff that you should be doing for your homework. They're assigned in your homework, but this is kind of extra credit. So if this is going to be a motivation for you to try to do that, then okay, let's see how well that works, if that's any motivation at all. For some people it is, for some people maybe not, but all right. So let's look at a navigation question, okay, you guys. So they're saying 2 boats leave the same port at the same time. All right, so 2 boats are leaving the same port at the same time. And let me let you guys know what that means here. Okay, this is where that port is. That's like the starting point. So here, 2 boats leave the same port at the same time. Now, one travels at a speed of 40 miles per hour in the direction of north 50 degrees east. So if I said to you guys, hey, what boat is that, north 50 east? Well, this is what they're talking about. Is that right? Let's do a little arrow here. So how we read this is really in relation to that first boat, north 50 degrees east. Now, I'm going to call that, I don't know, A, because what's the distance formula? Do you guys remember last week? Your distance formula from beginning algebra? Rate times time. So if I call that distance A, this is the rate is 40 miles per hour, and we need a time value. I bet it's going to come up. But when I read this, that's what I'm seeing here myself, okay? So there's your first boat. And then the other, you say, what's the other? There's 2 boats. So the other travels at what? 28 miles per hour in this direction of south, 80, south, and there's a typo. South what? 80 degrees. That's going to be 80. That's the southeast direction. We're going to call that B, okay, for the second leg. So that's B. We'll put that B here. So then B will be what? 28 times our time. We don't know what time is yet. But notice what the question is, right? What are they asking here? How far apart are the two boats after 3 hours? So in other words, they're asking for this distance here. And, you know, I'm going to call that D, but I'm going to say that's a different D than what you see here. Okay, this is your standard distance formula. Distance is rate times time. So that's a different D. I'm going to say don't even look at that D anymore. But we know what time is now. What's our time? Is our time 3 hours? So this will be times 3, and this will be times 3. So what we know is that A here, if we just move this now, A is going to be what? What's our A value? 120, is that right? I don't need my calculator for that. So that's 120 miles. That's A. Okay. Now, what is B going to be? Do you guys know what B is? Is that 84? Good. We don't need our calculator for everything, do we? So that'll be 84. We're going to have to get out the calculator eventually, though. 84 miles. And so they want to know how far apart are the boats after 3 hours. That's the D part. Okay? And yes, they gave us some time. So, ladies and gentlemen, what you need here to answer this question is an angle. And I make the claim you guys can get that angle. Right? Let me get out my calculator. How do I know you guys can get that angle? What angle is that? As I wake up the TI, what angle is that going to be? Do you guys know? Is that a straight line? So what does a straight line have to measure? Wish I had my sound effects. What does that straight line have to measure? Do you guys know? How do you get that angle? Uh-oh. Huh? A straight line should measure 180. Is that true? So what I'm saying here is you take 180 minus the 50. This is 50 degrees. And then minus the other 80 degrees. And what's 180? This is going to be what then? This is going to be 50 degrees? Is that right? It looks like this angle is 50 degrees. Because 180 minus 50 is 130, minus an 80 will be another 50. So this arithmetic here is 50 degrees. That's what we just determined here. That's the missing angle. Well, yeah, why is it? The point is, why is it 180? Do you guys remember? This angle, and this angle form a straight line. So the sum of those three angles needs to be what? 180. Now, another thing I want to mention to you guys is this. What are you going to use to find the distance? Is this law of sines or law of cosines? I wish I had my sound effects. Law of sines, law of cosines. What do you guys think? Anybody? Why is it law of cosines? There's a reason. No. Because we have what? Side. How did that happen? Side, angle, side. And we're trying to find what? The distance, this D here, that's opposite your what? 50 degrees. And we already know A is 120 and B is 84. So we have a side, angle, side situation. This is the known angle, the known side, and this is the known other side. So that should tell you this is law of what? Cosines, ladies and gentlemen. That's a law of cosines question. Okay, you're with me on that? Law of cosines? All righty. And that's why I gave you guys that work to do. right? That's why I did that. Because if you try to do it just the night before, what's going to happen? You're going to remember. So imagine if the Dodgers just practiced the night before a game or the Lakers. Huh? The what? I don't know. I wouldn't want to watch. I'd be like, okay. Anyway, law of cosines. Here we go. D squared equals what? You guys remember? 120 squared plus what? 84 squared minus 2 times 120 times 84 cosine of that 50 degrees. So like in my mind, again, there's very little I really memorize. And I want to make sure you guys see my point here. That with law of cosines, it kind of resembles a bit of what? Pythagorean theorem. It's not really, though, the Pythagorean theorem. And so now D is the square root of all this. And let me do this. So here we go. Let's get out the calculator. Where are you, calculator? Anyway, it's really... Here we go. All right, you guys ready to enter this? Here we go. Second square root, 120 squared, plus what? 84 squared minus 2 times 120 times 84 times cosine of 50 degrees. Close that. Ladies and gentlemen, what do you get? What's your distance? 92 point what? 2, and is that miles, I guess? I think that was in miles, right? So there's your distance D. Easy peasy lemon squeezy. 92.2 miles, and that goes right up in here. That's your distance here, 92.2. We're going to go out to the nearest tenths. We're going to be a little bit more accurate. Okay, 92.2 miles. This was a side angle side scenario, and there you go. And that's it. There it is, let you guys. Easy peasy lemon squeezy. Law of cosines question. And then notice what they did. They just integrated language of bearing and heading, and that's it. That was the new wrinkle. Language of, how to get those angles there. So these are just classic kind of questions in a trig course. This is why you study law of sines, law of cosines, in all honesty. This is one. If you don't do applications, it's like, why are you studying these kind of things, right? And the applications, even though they have words, they're not too bad. Okay, they're not too bad. So take a look at this one here. This is exactly the same. This is the same kind of question. Okay, navigation. 2 boats leave the same port at the same time. It's the same. And again, this is where the port is, as you guys know. It's right there at the origin. Even though you say, well, that's not really not an origin, that's a compass. Well, kind of. So there's your port, right? You're leaving the same port at the same time. One travels at a speed of 40 miles per hour in the direction of north 50 east again. Oh, okay. North 50 east. So that is northeast. There's your 50. We'll call that boat A again. So A will be 40. Notice it's going to be the same thing. That's 120. And it's in miles. Okay? Because they're telling you here, looks like when I did this, I pretty much kept that one the same. And the one I changed was some of the new language. The other travels 28 miles per hour in the direction due south. And, oh, what happened? What happened? Where'd you go? Weird. 28 MPA miles per hour due south. So the one's down here. That's what I wanted to show people here. Okay? So this is B now. And B will be, oh, it was 28 times 3. So that's 84. So, okay. So, you know, we're doing the same kind of thing. So there's 84. I'm going to move this here. All I'm changing was the direction. So A is 120, and B, and that's in miles, is 84. And I know what they're going to ask, how far apart are the boats? That 3-hour difference again, it's just boat B is in a different direction now. Okay, there's your boat D. They're going to ask, not boat D, sorry. They want to ask, that's the distance D, how far apart now? However, you need an angle right in here, don't you? Well, I don't, is it a right angle? Be careful. It's not a right angle. It's not a 90-degree angle. How do we get the angle of that triangle? Now, you might say, what triangle? I know my colors are the legs here. One leg is orange, one is green, and the hypotenuse, it's not even a hypotenuse anymore. Just the longest side is purple. So you're looking at a triangle. So in other words, anybody know, how do I get that angle? How do you get this angle? What do you guys notice? Again, don't you have this angle and this angle form a straight angle? So what is that? 180 minus now what? 50 degrees. What does that give you? 130. So this angle now, and that's really the essence that I wanted to do for people, is illustrate to them that by changing one direction of one boat, going simply due south, to compare and contrast here. You know, with the prior example. So now that angle that you're going to use for, is this law of cosines again? How do you guys know this might be law of cosines? You have side, angle, side. Isn't that law of cosines? So we should have called this really a law of cosine application. What's law of cosines? Again, law of cosines, ladies and gentlemen. This is going to be now what? D squared again will be 120 squared plus 84 squared minus 2 times 120 times 84 times the cosine now. What's the new angle? 130 of 130 degrees right in here. See my point? What's your D? Square root of all these things. So this is just like the last one. It's just that your direction gave you a different angle. So now let's use log cosines in our calculator again. Second square root 120 squared plus 84 squared minus 2 times 120 times 84 times cosine of, what is that? 130 degrees. What do you guys get for that distance? What's that going to be? 185.5 what? Miles. There's D. 185.5 miles. That's your distance. And there it is. Law of what? Cosine. So that's why